Picture this: a house sitting in the middle of a village. No scaffolding, no construction crew, no renovation notice on the door. It has been standing there since 1520. The roof has not been replaced. The walls have not been patched. The foundation has not shifted. 500 years of rain, 500 years of frost, 500 years of summer heat and winter storms. And the house is still standing, still straight, still solid, still dry inside. Now picture the house you live in today, built maybe 15 years ago, maybe 20. The roof already needs attention. The damp patch appeared after the third winter. The cracks crept in around the window frames. The plaster is bubbling in the bathroom corner. The developer gave you a 10-year structural warranty. 10 years. That is not a guarantee. That is a confession. Somewhere between 1520 and now, we stopped building things that last. And the question nobody is asking loudly enough is, why? What did builders 5 centuries ago understand about permanence that the entire modern construction industry has quietly abandoned? Walk onto a modern building site and you will see progress. Cranes, prefabricated panels, fast-drying concrete, steel frames bolted together in days. A house can go from empty plot to finished structure in 12 weeks. 12 weeks. It looks impressive, but here is what they do not show you. That same house, built in 12 weeks, is designed to last 30 years. Some are rated for 50 if maintained well, not 500, 30. The industry calls this design life. But there's another name for it: planned impermanence. You don't own a home built to outlast you. You own a product built to need replacing. And that changes everything about how it's constructed. Because when your goal is 30 years, you do not need lime mortar that gets stronger over time. You use cement that cures fast and cracks faster. When your goal is 30 years, you do not need 2-foot stone walls. You use hollow block filled with insulation that compresses and fails within a decade. When your goal is 30 years, you do not need hand-cut joinery that locks itself under load. You use nails and adhesive that corrode and separate. Speed and cost replaced permanence. And nobody told you. So what did those 500-year buildings actually use? Let us start at the very beginning. The foundation. In medieval and early post-medieval construction, foundations were not just dug, they were read. Builders studied the land before they touched it. They looked at where water collected after rain, where the ground stayed dry, how deep the frost penetrated in winter, and which way the slope drained. They were not guessing. They read the site like a document, and they dug until they hit stable ground, not just legal depth. Sometimes that meant going down 6 feet, sometimes 10, sometimes more. Then they laid rubble, stone, and lime at the base, not to block water, to breathe with it. Here is what almost nobody understands about traditional foundations. They were not waterproof, they were water tolerant. Modern foundations try to stop water completely with plastic membranes, damp-proof courses, and sealed concrete slabs. And when that seal breaks, even slightly, water enters and has nowhere to go. It builds up. It saturates the wall. Damp rises. Structure weakens. Traditional foundations let small amounts of moisture pass through, slowly, and evaporate. The wall could breathe. Moisture moved through it instead of being trapped in it. This is called vapor permeability. And it is the reason 500-year-old stone cottages have dry internal walls, while modern houses with damp-proof courses develop rising damp within 20 years. The old system worked with water. The new system fights it. And when the fight is lost, the damage is severe. Now move up to the walls. Traditional walls were thick, not for insulation, not for strength alone, for regulation. A typical stone or cob wall from the 16th or 17th century ranged from 18 inches to 36 inches thick. Some were wider. That thickness did something modern walls cannot do. It buffered everything: temperature, moisture, sound, pressure. When it was cold outside, the wall absorbed the temperature change slowly, releasing stored warmth gradually into the interior. When it was warm outside, the wall absorbed solar heat, holding it in its mass, delaying its transfer inward. The interior of a properly built, thick-walled traditional home did not experience the temperature extremes outside. It experienced a smoothed, delayed version of them, a kind of thermal memory. The wall remembered yesterday's weather and moderated today's interior accordingly. Modern walls have no such memory. A standard modern cavity wall is maybe 12 inches total. Brick outer leaf, air gap, insulation batt, block inner leaf, plasterboard. The insulation resists heat transfer, but it has almost no mass, no storage capacity. When the heating goes off at night, the interior cools almost immediately. When the sun hits in the morning, heat passes through within the hour. The house has no buffer. It reacts instantly to every external change. And so does your energy bill. But here's what makes the old wall even more remarkable. It was not just thick, it was alive. Lime mortar, the material that bonded every stone or brick in traditional construction, is not inert. It continues to react with carbon dioxide in the air for decades after it is laid. Decades. This process is called carbonation, and what it produces is a joint that gets harder, stronger, more crystalline year after year. A wall built in 1550 with lime mortar is stronger today than it was in 1560, because the mortar has been hardening for 500 years. Hardening. Now compare that to modern cement mortar, cement. Cement reaches most of its strength within 28 days. After that, it does not improve. It just sits there until it cracks. And when it cracks, it is rigid. It does not flex. It does not self-heal. It does not reknit. Does not. Water enters the crack. Frost expands it. The joint fails. Lime mortar behaves differently. It is slightly flexible. When the building moves under load or settles slightly or expands in heat, the lime joints absorb that movement. Micro movements that would crack cement are accommodated in lime. And here is the detail that changes everything. Lime mortar is softer than the stone or brick it holds. This is intentional. In traditional construction, the mortar was designed to be the sacrificial element. If stress had to go somewhere, it went into the joint, not the stone. If damage had to occur, it occurred in the mortar, not the structural material. And mortar can be repointed. A single craftsman with a trowel and a bucket of lime can restore the joints of a wall that is 400 years old in a week. The structure beneath, untouched, undamaged, still original. Modern cement mortar does the opposite. It is harder than the brick it bonds. So when stress moves through the wall, it moves into the brick. Bricks crack, faces spall. Structural material is damaged. And once the brick is gone, it cannot be repointed back to life. The wall is compromised at its core. That single material decision, lime versus cement, accounts for a significant portion of why old buildings last centuries and new buildings last decades. It is not a mystery. It is a formula. A formula we replaced in the name of speed. Now let's talk about the roof. In traditional buildings, the roof was not a separate system bolted onto the top. It was an extension of the structure. Heavy timber frames, peg joints, no metal connectors. The wood was selected carefully. Slow-grown timber from mature trees. Why does growth rate matter? Because slow-grown timber has tighter annual rings. Tighter rings mean denser wood. Denser wood is harder, more resistant to compression, more resistant to rot. A beam cut from a 200-year-old oak is fundamentally different material from a beam cut from a 30-year plantation pine. One grew slowly, under competition, in varied soil. The other was forced to grow fast, in rows, fed with fertilizer. Fast-grown timber is softer, more porous, more vulnerable to moisture and insect attack. It can be treated with chemicals to resist these things. But treatment fades. The density of old-growth timber doesn't. Traditional roof frames were also built with something modern roofs have largely abandoned. Redundancy. Multiple members carrying shared loads. If one timber developed a crack or a split, the load redistributed across the others. The roof did not fail, it adapted. Modern engineered roof trusses are optimized to carry load with the minimum material. Every member is calculated to do exactly its job and nothing more. Efficient, but fragile in failure. If one critical connector fails, the load path is broken. The truss does not redistribute, it collapses. Medieval builders did not have engineering calculations, but they had something equally powerful. Intuition built from generations of observation. They knew which roofs lasted and which ones failed. They knew because they lived next to them for lifetimes. That knowledge was passed from master to apprentice, hand to hand, sight to sight. Not written down, not codified, just practiced. And the result was a roof system that could outlast the builders who made it, and the builders who came after them. Now think about what we replaced all of this with. Cement instead of lime. Fast-grown timber instead of slow-grown. Thin walls instead of thick. Sealed foundations instead of breathing ones. Optimized trusses instead of redundant frames. Every single substitution made the building faster to build, cheaper to produce, easier to deliver at scale, and shorter in lifespan. We did not lose the knowledge of how to build things that last. We made a decision that lasting was no longer the priority, and that decision has consequences, not just for buildings, for the people inside them, for the resources consumed rebuilding them every generation, for the waste produced when they come down, for the carbon emitted constructing them again. A house built to last 500 years is built once. A house built to last 30 years is built and demolished and built again 16 times in that same span. The materials, the energy, the labor, the waste, 16 times. And we call the modern approach efficient. The deeper you dig into traditional construction, the harder it becomes to accept that explanation, because the evidence is still standing, literally. In villages across England, France, Germany, Scandinavia, and the Middle East, houses have outlasted the civilization that built them. Not ruins, not museums, homes, with people living inside them today. No repairs, no major interventions, just time, and the right materials, and the understanding that a building is not a product. It is a promise to the next generation, that what you build will still be there when they need it. Modern construction broke that promise, and most people do not even know it was ever made. Picture what happened after 1945. The war was over. Millions of people needed homes fast. Governments did not ask how to build well. They asked how to build fast. Lime kilns shut down. Cement factories scaled up. Timber plantations replaced old-growth forests. Prefabricated panels replaced hand-laid stone. In less than a single decade, 5 centuries of building knowledge were set aside. Not disproven, not improved upon, just abandoned. Speed was the emergency, and when the emergency passed, the industry that grew from it did not want to go back. Here is the uncomfortable truth. A house that lasts 500 years is a house that never needs to be sold again. No renovation contracts, no re-roofing jobs, no damp-proofing companies, no replacement window industry. A permanent building is a terrible business model. A disposable one generates income forever. So the knowledge did not disappear by accident. It became inconvenient. But something is shifting now. A small number of builders across Europe and North America are returning to lime, to thick walls, to slow timber, to breathing foundations, not for nostalgia, for performance, because their clients are tired of repairs, tired of energy bills, tired of buildings that feel temporary. They want what people in 1520 had, something built to outlast them. The methods still exist. The materials still exist. The knowledge mostly still exists. What is missing is the will to accept that faster is not always better. And cheaper up front is not cheaper over 500 years. The old builders knew something we forgot. A house is not finished when construction ends. It is finished when it is no longer needed, and the best ones never stop being needed. Thank you for watching this video. Click here to watch another video that might interest you.